Hello, everyone. My name is Sergey Maschenko. I'm from Sharcnet, Compute Canada, based at McMaster University. And today's topic is New User Seminar Part 2. Some of you may be aware that we, Sharcnet, deliver regularly our new user seminars live every Tuesday at 2 p.m. Eastern Time. And these are aimed at new users, obviously, those who have little or no knowledge about Compute Canada national systems. The problem is it's only 1 hour long, and we cannot cover all the topics of interest, of potential interest to new or recent users. Hence today's webinar, which is designed to fill out those gaps. So today's webinar is aiming at new or recent users of Compute Canada systems, and I will strive to cover multiple topics of potential interest of new users. And here's the outline. I may be a little bit ambitious. I'm listing quite a few things I want to cover. But realistically, what I'll be doing, I'll be showing 1 slide per each of these subtopics, and which contains a reference, a link to a much more detailed wiki page description of that topic. And most of my time will be spent in live demonstration. So let's get started. So first subtopic, interactive jobs. Here's the main reference. I can just, for once, click on it to show you that it's taking me to docs.computecanada.ca, our wikis, the main source of information. And as you can see, it has lots of information, much more than I can possibly cover today. Instead, I will concentrate on the main points. Okay, back to the topic. You probably are all already familiar with the way to run jobs on Compute Canada national systems. You use sbatch command. You create a short job script. You put a few arguments for the sbatch command, such as runtime, memory, how many CPU cores, and you execute with the sbatch command. Not all of you may be aware that it is allowed for certain limited types of application, it is allowed to use our resources interactively. And I'm emphasizing here, it's not for regular compute-intensive jobs. It's more for like quick tests, debugging, profiling, maybe some visualization, things like that. We allow users to use interactive resources, which are set aside for these specific topics. And to make use of them, instead of sbatch, one has to use another Slurm scheduler command, which is salloc, which accepts, in fact, all the same arguments as sbatch, the same for runtime, account name, and so on and so forth. The only difference, you don't need to create a job script. Instead, you provide them as command line arguments on a single line, as I will show you in a few minutes. It's not just for serial jobs. You can do multi-threaded, MPI, or even using GPUs. It's all acceptable. You should be aware there is a limit of 24 hours imposed on all these interactive jobs for a very good reason. Interactive jobs tend to be very wasteful. Most of the time you do nothing. You just sit, not using CPU cycles because it's interactive. Another thing you have to be aware of, there is a limited number of nodes set aside on each cluster for this interactive use. Sometimes you're lucky, you almost instantly get access to your interactive shell. Sometimes you have to wait an hour. Also depends how much resource you want asking for. So this is this slide about this topic. Now I'm switching to my live demonstration. So I'm already logged into Gram login node, Gram cluster. I'm inside a special directory I created for this webinar, and I'll go inside interactive subdirectory. So as you can see, there are a few test codes here, but basically I'm going to demonstrate how to request an interactive node for simple tasks. So let's use it now to request a single CPU core short interactive session. So as usual, I have to ask for time. These are usual sbatch arguments. Let's say 0 days, 00 hours, and 10 minutes. I'm going to make it short. I'm asking for 1 CPU core. I'm going to be using special account, but use whatever you normally use, def, your supervisor name, or your personal name. In this case, I'll use special CC debug, so it gives me faster access. This account is not accessible to normal users, just for stuff. And then, as usual, I'm asking for a certain amount of memory, --mem, let's say 4 GB, which is sort of average amount of memory per CPU core on Graham system. That's all. If the interactive partition, the nodes set aside for interactive use, are not particularly busy, I should almost instantly get access to interactive shell. Also, it helps that I'm using staff high priority account. In your case, you may wait a bit longer. So you get standard job ID, but what the difference with SBatch, you actually being taken to a particular compute node, in this case, whatever it happens to be Graham 23, and there I can execute my commands interactively. I can compile code, debug. If I want to run some things using, which requires GUI interface, graphical user interface, it's slightly trickier, so I'll be explaining exactly what you need to do. If you did what I just did, by default, you won't be able to run a GUI application. But let's try it with Xterm. It complains it cannot open display. So what I should have done, if I plan to do something interactively and graphically, like DDT debugger, for example, which requires GUI interface, what I have to do, I have to exit, and I have to add one more command, --x11. Sometimes it's flaky, sometimes it produces errors, so it's not super reliable. Also, it's not the most efficient way to run graphical application. A much better way is to use VNC mechanism, which I'll explain at the very end of this webinar. But for now, just as a demonstration, I'm using --x11. So if you set up your own computer with proper X11 forwarding, I don't have time to explain, look up our information on the docs.computecana.ca. Then at this point, if you type Xterm, you will see actual graphical application. If, for example, you're a Windows user and you install and using MobXterm application, which we highly recommend for Windows users, then this X11 server feature is already enabled and running by default. So that's all you need to do, the things I just demonstrated. Okay, perfect. So it all works. Let's see how to do things in parallel. Let me, for now, remove this X11. Sometimes it's flaky, so if you don't need it, don't use it. For MPI, as usual, you just choose number of cores you want, and for MPI, you want to use command mem per CPU. For each MPI rank, you request 4 GB. And again, a very short 10 minutes run. Okay, so now we can run MPI codes using either srun, as usual, and it will use the number of cores I requested, which is 4. You can also use MPI run. I don't know what's going on. For some reason, MPI run is not visible. Oops. Okay, I was playing with my environment. So let's say module. It's a feature I was going to explain later, but I'll just use it here. And MPI run. Sorry about that. Small issue. So it runs, and in fact, you can even request fewer. If you need just 3 within your 4 allocation, you can do that with MPI run explicit. All right, and for multi-threaded, like OpenMP code, as usual, we replace -n with -c. It's number of threads you're asking for, in this case 4, and you request for the total memory. Let's say 4 GB for all 4 threads. And then we get access to these resources, and then I can execute my OpenMP hello command. And as usual, you can modify behavior with OMP num threads. If you say 3, then my OpenMP code will be using 3 out of 4 available. So it's all easy. By the way, if you allocated interactive node for OpenMP code with -c, as I did here, you will not be able to run MPI run or srun. You won't be able to run your MPI hello. Keeps doing this again. Never mind. So, or srun, for example. So you actually have to allocate it with -n for MPI usage. And in terms of GPU allocation, you do the usual stuff. You ask for, let's say, 1 core, and then you ask for --GRE is equal GPU. Let's say only 1 GPU. A more advanced version of this command I'll be demonstrated in a few minutes. So we're trying to get access to a GPU node. We just granted access, and we can run GPU commands. As you can see, we have access to the GPU, which is P100. So in fact, what I have to do, module reset. Yeah, okay. That was a small technical issue. Okay, so we covered this topic and of interactive use. It's very useful. You're welcome to use it for quick test and debugging profiling. Just be aware of limitations, 24-hour limit. And you're not supposed to use this resource for compute-intensive tasks. This is primarily for, interactive use. Switching to the next topic, requesting alternative GPUs. So let's switch gears. Some of you who do need to use GPUs for your computations are aware that we have decent GPUs installed on our national systems. For example, on Gram, if you execute command I just showed, you gain access to our default GPUs, which are P100 NVIDIA GPUs. They're very powerful, great for general purpose computing, but these are not the only type of GPUs we have. You should be aware that we also have 64 V100. These are even more powerful, the same sort of general purpose GPUs, 1 generation newer Volta GPUs. If you're out of Ontario user, you have a runtime limited to 1 day. And we have even newer generation, 144 T4 GPUs, which are Turing generation. They have Turing tensor cores, but have very little support for double precision. So these are not general purpose GPUs, but they're great for machine learning and such. So how does one gain access to non-default GPUs? The same GRES command I showed you just a minute ago. The only thing you have to add the flavor of GPU you're asking for. So let me demonstrate that. So I just did this command. Either inside salloc or inside your sbatch job script, you just have to add. Let's say we want to have access to V100. So we add V100 column. I've noticed they're pretty busy, quite popular, so we may not be able to get access to one of these. I'll just wait a few seconds. No, they're pretty heavily used. But T4s were fairly available, so let's try that. Yeah, so almost instantly. I got access, and then if I execute NVIDIA-SMI, I can tell that my GPU is Tesla T4. Again, these are not good for general purpose, like double precision is horrible, so don't use for general purpose GPU computing. But for machine learning, it can be very good because it has dedicated tensor flows. And we have quite a few of these T4 cards. So you're very much welcome to use these non-default GPUs on Gram. On Cedar, they don't have these T4s or V100s. Instead, they have L GPUs. So if I go to Cedar, I'll just copy this command. I'm going to Cedar. And instead of, I'm going to say L GPU, and that should, okay, Cedar has a little trick that you have to go inside project space to be able to submit jobs. Okay, I don't want to spend time on this, but basically to be aware, with L GPU, I think it tells me to use 4, only the whole node can be accessed. You gain access to non-default, which is still P100. Okay, so I can't even use it for interactive, so I have to do it inside the job script. But LGPU stands for P100 with extra memory, 16 gigabytes. The default type of GPUs on Cedar are 12 gigabytes. So if you need P100 with more memory than default on CEDAR, then you make use of this special extra argument. Switching gears to the next topic, installing software yourself. Most likely, software you need is already installed on our systems. Sometimes, for whatever reason, you want to install it yourself. For example, you need a bleeding edge, like beta version of certain package, which is already installed, but you need a newer version. You can ask us to install the newer version, but it may take a while, sometimes weeks. We have a few software staff which work full-time, keep installing new packages. So it's not super fast way to get what you want. Sometimes you need to customize a package which is already installed. A typical example, PETA-C, a library for linear algebra, which comes with so many different things you can add optionally, so we can't possibly provide everything you might need in an official package, so you may need to recompile it yourself. Or perhaps software you wrote or your research group wrote yourself, so you want to compile it. First, many standard packages, open source packages, use approach, configure, make, install. And this seems to work with standard open source packages, as I will show in a second. Sometimes you need to load certain modules, certain libraries this software depends on, and sometimes it will tell you what it needs. Sometimes it's more obvious, sometimes it's less. The thing you need to know for sure that when you run this configure command, you have to provide a custom prefix. Otherwise, by default, it will try to install things in system level directories, which are root only accessible. So it will fail. Your make install will fail if your configure lacks this command. And there you have to provide your project or home file space local directory. So let's try that with one standard package. And I'm going to back to Graham cluster, and I'm going to installation subdirectory. So he already downloaded a package, which is netcdf. It's a standard library, maybe slightly newer version than what is currently installed. So maybe that's the reason why you would want to compile it yourself. But here I'm using just an example. To get this, you can use wget from login node and then provide full HTML address of that particular file. I already downloaded, so what I have to do, I have to unpack my tarball. Okay, and then we go in, it creates a directory. So netcdf, we go inside a directory. And then we have to create a directory where we're going to install our stuff. Let's do it inside project space, and let's call it netcdf. So we are currently in a compiling directory, source directory, and this is what we create in the installation, where it will be installed once it's compiled. And then inside, we see the standard configure package, configure command, sorry. And many open source packages have this standard way of compiling. So start with configure, but don't forget the prefix command, as I just explained. And I will provide full path to my project slash the directory I just created. Sorry, I made a typo. It should be prefix. Okay, and the error was can't find HDF5 library. So this is an example that a package you're trying to compile depends on other software packages. And HDF5 library hopefully is already installed on our system. To double check, you say module spider HDF5, and it tells you there are multiple versions. Most likely we will be fine with the default version. So let's load this module and quickly rerun the configure command. Pay attention to the output of this configure command. Make sure it makes sense, it's sensible, because depending on your environment, depending on which modules loaded, not loaded, it may not support all the features you want. In this case, HDF5 support is enabled, and there are other things which may be of importance to you. So make sure everything you need is actually supported. And now we can compile. So after configure, you follow with make, and we want to use, let's say, 8 cores to make it faster. So -J8 means it will be using 8 CPU cores on the login node to compile everything we need. So it will be really fast. Compiled and followed by make install. If you get an error message at this point, which means you forgot to put -- prefix command in your configure command, which means you have to redo from the beginning. Now everything is installed inside your directory, netcdf capital, which I created. And if you want to make use of that stuff, so if you have a look what's inside the directory, netcdf, this is a standard format. It has lib directory or subdirectory, it has include, and those typically you have to provide to your code when you compile it, when you link against this library. But sometimes software is not smart enough to find all the libraries it needs based on the current environment. So remember the thing I just did, I said module load HDF5, and my configure make commands found all those library files by magic. Of course, there is no magic. If you check the environment, each time you load a module, it modifies environment variables such as library path, cpath, and path, and so on. And those libraries contain the paths you need to find the library and compile and link against it. Some standard packages, open source, like netcdf, knows how to make use of this information. Others may not know that, and you need more manual intervention. So I'll show you using another example. So going back, so there is a single file which is using parallel version of fftw library. And this is an MPI command. I already know, I read the documentation, I need to load HDF5 MPI version. So first maybe I want to check module spider FFTW. If I don't know exactly the MPI version name of the module, so here we find there is one, it's called like this. So then we module load FFTW-MPI, and now I can try to compile using npicc. And this is the name of the file. So another thing, I need to know that I have to link to specific libraries. Again, for this you need to read documentation of the program you're trying to compile. In this case, I need to link against FFTW3_MPI and also LFFTW3. And in fact, these programs I'm using, the environment is smart enough, again, to find those FFTW library and include files. It's like by magic. Sometimes this doesn't work. If it fails, you can be more explicit. You can actually tell your makefile or your compile command where to find these files. How? So there is a command environment. It lists all the environment variables. This can be a very long list. We're going to grab to see only the ones starting with EB root. I'll show you in a second. I'll tell you why. Basically, every time you load a module on our systems, it creates a new environment variable which always starts with EB root and then contains the name of the module. So for example, FFTW variable is EB root FFTW, and it contains the path to the top level directory containing that particular package. And the beauty of this approach is that you may reload module, you may load newer version of this library, older version, or maybe you change your compiler. This all changes the full path to the library. But if inside your makefile you're using the variable rather than the actual absolute path, then your compile script will be very flexible. You just reload module and it will still work. You don't have to edit it. You don't have to change it. So in our example, let's have a look what's inside this. In a typical library or package, or in this case FFTW, inside you have standard lib, bin, and include. So we can use those to provide full path to our compiling script or our makefile. So how to do that more explicit way? We say -L. That's the way to provide full path to your library files. But instead of full path, we use the environment variable /lib, because that's where it's residing. Same for include files. The same, but /include. So now, if the simpler version of my compile command fails, it cannot file either library files or include files, this more explicit way, maybe that's all we need to fix the problem. So now I explicitly told my script where to find library files, include files, and it did found them. Compile file without errors. All right, so let's switch gear once again, and let's talk about advanced use of the module command. Attending the normal intro webinar, you should have learned what module commands is for. It is to load, unload, list, etc. software packages installed on our system. By default, most of the software packages are not accessible. You have to say module load. So you should have learned the basic commands: module list, to list modules which are already loaded; module spider, it's sort of Google search for whatever modules which can be loaded; and to load specific version, use module load; to unload it, use module unload. So let's talk about slightly more advanced module commands. So one of them would be module reset. You actually saw me already doing that because I messed up with my environment. And this exactly is for if you mess up your environment. And let me show how you can mess up your environment. For example, you can say module purge. And that removes many modules. Or maybe you are even more adventurous, you say --force. And that removes all the modules, even the ones which must be loaded. If you say module list, nothing is loaded. And that's for sure broke a lot of things for me here. So if you're at loss, either you loaded too many different modules or you did something like module force purge, to the rescue is module reset. If you say module, sorry. If you say module reset command, okay, I'm back. Module reset, that your system goes back and you say module list, all your standard packages are there, so you're safe. So module reset is very useful command. And then we can also use save, restore, save list, and disable. How to use these commands and what are they for? Let's say, as an example, I want to load FFTW, the most recent, the newest version we have on the system. So I'm going to say module spider FFTW, and this is the bleeding edge version we have, the newest. How to load that? Sometimes it's not, if I just say module load, sometimes it fails. Especially if you want the newest version, it doesn't load, but it tells you how to fix that. In this case, it tells you how to find out how to fix it. So you have to execute module spider. And that usually happens when you need to load first some other modules before you can load the one you want. There are some dependencies there. And you can choose whatever you want, either use GCC this version, this, or Intel this, which is non-default Intel. The default is 2016. So in fact, it needs newer version of Intel compiler, and also it needs special NICS packages. So, and then I can load my package, say load, and then I list the ones which are dependencies, and then I can list the one I want at the end. Now I'm actually loading and reloading multiple packages, so it's quite a different situation now. It's quite tedious, so every time you need this bleeding edge FFTW, you have to do these multiple steps. How to simplify the situation? And there is a way. You can say module save, and then you give a name to the particular custom combination of modules you want to preserve. Let's call it FFTW. And that means we now saved all the modules we just loaded, custom modules, as a special list. To see the list of all the combinations we saved, we say module save, I think it says save list, yes. So you can see an older list I saved earlier, which is I called R, obviously dealing with our package, and this is the one we just saved. And then if you do things like module reset, so we are back to, or let's say you logged out and then logged in, and then you're back to the standard set of modules. And to go back to the ones you need to use FFTW, you maybe, to remind yourself, you do module save list. Okay, so this is the one you need. And then you say module restore, and then the name you've given to this list. And it is a module list. Now we can see not just this module, but all the rest were updated. Now you can instantly start using with your newest version of FFTW library. At the end, if you don't need this list anymore, you can say module disable. And then if you say module save list, it's no longer listed there. Very useful if you often deal with the newest version of certain software packages. Switching topics. When you need to copy data between different national systems or between your computer and a national system, you probably usually use command line tools like scp or rsync. That works perfectly fine up to a point. If you need to copy lots of data, let's say more than a few gigabytes, this approach either becomes non-reliable or just consistently fails, especially if you need to copy tens or hundreds of gigabytes. It just fails for multiple reasons. Instead, the best way, or maybe the only way, to achieve the task is to use a web-based tool called Globus. The detailed documentation is available here. Usage is very simple. You basically go to this website, globuscomputecanada.ca. Let me do that. I'm going to click on this link and go to my browser. And then it will ask you to, first of all, find the organization. It already remembers, but just type, you can type it here, Compute Canada, then find, and then it will remember from now on. Then you click continue. It will ask for your Compute Canada credentials. So I'm going to use mine to sign into the online interface. And if you need to copy files between two national systems, then it's very easy. First, make sure you have not a single panel, which is, I think, default, go to two-panel version, and you're inside File Manager tab. So you have two tabs, and either of the side can be source or destination. So you search for cluster name, basically. If you want to copy from Graham, you search for Graham. And what you need is called DTN node. It's a data transfer node. So each of our cluster has dedicated resource and node for Globus support. So we choose Graham DTN to copy files from project, Scratch, or home on Graham. And if you need to copy it to, let's say, Cedar, the same thing. We are looking for Cedar DTN. Ignore the other things. You need Cedar DTN. Okay, so, and sometimes it would ask you for re-authenticate you on Graham. It remembers for a while and then it forgot. So I'll have to type again my credentials for the Graham cluster to be able to see local files on Graham. Okay, let me quickly go back and to make sure. Okay, not sure why it happened. So now I'm just hit twice, go back, and now it lists all my files on Graham. Happened first time. So now we can see my source. Either of them can be source or destination. Let's say I want to copy a file called, by the way, I can go inside project space. I have lots of files, so project. I can go inside project, and it will give me a list of project files. And let's say I want to copy this file to Cedar. And in Cedar, on Cedar, let's say I want to, Cedar, I want to make sure. Okay, now it lists file. Not inside my home, but let's say inside Scratch. So from Graham project, I'm copying to Cedar Scratch one particular file. You can also copy multiple files or folders and so on. And all you need to do is click Start. It tells you it's submitted, so you initiated this command. And you can go to Activities tab on the left side. And in fact, it already finished. Sometimes it takes a bit longer. So it's not for small files copy. There is some overhead, some delay, but copying gigabytes or more of data, this is the best or the only approach. Once it's done, maybe in a minute or so, I will receive a confirmation email, which is also convenient, or you can just log in back and see activity. So if we go now to Scratch and Cedar, so I'm going to, so you can see the file I just copied, so it's there. Or I'm going back to my browser, activity, I can go click and see all the details I need to know. This is a very reliable way. If internet goes down or there's some problem with the cluster, etc., it will succeed eventually. So it is very reliable way to copy data, and the only way if you need to copy lots of data. If you need to copy data from your own personal computer, you have to do one extra step. So after you log into this online interface, you have to go to endpoints. There you go here, create a personal endpoint. You give it a name. Let's say I'm giving this name, and then generate setup key. It's successful, and then you have to download and run a small program, which is different from Mac, Linux, or Windows. I already did that for my computer, which is Linux. So I go to my Linux local file system. This is the program I downloaded, and this is the one I need to run, Globus Connect. Nothing to install, nothing to compile, sorry, but something to install and run. And here I have to click Connect. And once it tells me connected, I can go back here. I can go back to File Manager, and now I can copy, let's say, from Graham to my personal. The name I just gave, SYM2, it's listed here now. As long as you run that little program there, it will be, so it actually thinks it's not running. Maybe because I gave two different, for the same computer, so the one I did before, it's called SYM, and it's in green. Okay, so don't create more than one endpoint per one computer. So in this case, as long as I'm running that small program on my computer, I will be able to see, these are my old local files on my local computer, and I can copy back and forth from my computer to one of the cluster and back. Very convenient for copying large amounts of data. Switching gears. Now let's talk about automation of job submission. Sometimes your workflow requires you running multiple similar jobs, sometimes hundreds or even thousands of jobs. This is what we normally call farming. Could be serial farming, MPI farming, or GPU farming, depends on kind of jobs you're running. This can become quite tedious. So let me show two tricks how to have a convenient workflow to run so many different jobs. A simple approach is to use so-called job arrays feature of our scheduler, which is Slurm. Let me demonstrate that using a particular example. So I'm going back to Graham cluster, automate, and I'm going inside job arrays. I already created a job script. So the only twist or trick you need to learn to run job arrays is to modify a job script in such a way that it makes use of the special variable slurm array task ID. So just think of this, when you submit this as job array, and I will show you in a second how to do that with sbatch command, you will have multiple instances of your job running, of your job script executed. Each of them will have a unique value of slurm array task ID. For example, you're running 8 versions of your job, and this slurm array task ID can have values 0, 1, 2, 3, up to 7. And then you just program your script to interpret that variable the way you like it. to customize the job execution. In this case, I create a local subdirectory which contains this variable as a part of the name. So I create unique subdirectory for each of my sub-jobs. I go inside the subdirectory and then run my code. In this case, I just say echo the value of this job, of this variable, and I create local output file inside each individual subdirectory. And I just sleep for 30 seconds just to make it a little bit longer. So once you modify your job script to make use of this slurm array task ID to customize execution for each of these sub-jobs you're trying to run, then you use the usual as batch command to submit the whole serial farm as though it's a single job. But one extra argument you have to provide is --array, and then you provide a range of the indexes of each of these sub-jobs. Let's say 0 to 7. And this is a very flexible way. So you can modify these numbers, and you can run different serial farms with different number of sub-jobs and different indexing. For example, you can start from 1 to 8 or whatever you want to do, or you want to go up to 10. It's very easy to change from command line, and then you hit execute. And it appears as though you only running one job, but in fact, and it looks like one job here. So it may be cluster is busy. But these are in fact multiple jobs which will be executed independently. It is running. So it's running, it created all those subdirectories, and I use the index environment variable as an index of each sub-job. So inside each of subdirectory, I create output file, which, if you remember, contains the value of that variable, which in this case is 5. So it's very convenient to submit lots of jobs. It's easier to submit, easier to kill them, and easier basically to set up. But it's not very powerful approach still. For example, you need to run thousands of jobs. Some of those jobs fail for whatever reason. Maybe the node crashed, maybe there was power down or shutdown of the whole cluster because power outage, and you lost some of those jobs. It can be very tedious to recover which of your thousands of jobs actually ran, successfully ran, and which of them never ran or failed. For that, you use another feature. You use a meta package which was created in-house. So let me show you very quickly how to do that. And I'm going back to my slides for the instruction. So you have to execute this command. So we are copying the scripts for this application from our Git repository. So let me do that. And I believe it still remembers my command. I'm too lazy to type it from scratch, but this is the command I just executed. So it created this meta directory. We go inside. And basically what you need to do is to provide or modify path variable, your environment variable, to make files located inside this bin subdirectory on the path. So there are a bunch of scripts available here, and you need all of them to be on your path. For example, you can say export path equal local directory name /bin column and then standard path. And now any of these commands can be run anywhere. So we can say submit, and it runs it. Or we can ask which submit, and it tells me it's the one located right here. Okay, so that you do it only once at the beginning when you install the package. And then basically what you need every time you want to run new serial farm, you have to modify job script. At the very least, you want to change the account. It contains my account name. You want to put something else. Maybe I'll be using my debug special account, or you have to use your own account. Modify runtime for each of these jobs you're going to run. Memory, maybe number of cores, and so on. Don't change this line. So we did that. And it already comes with examples. To run a serial farm, you have to create a text file called table.dat. You already have one example of that. Each line of this file is the execution command you want to execute by individual jobs. So just imagine each of these lines will be executed as a separate job. It can be prepended with the line number, but it's optional. If you don't do that, it will do it automatically for you. Here it's prepended. And my commands, I'll try to run as separate jobs. They're very simple sleep commands. I just sleep random number of seconds. That's all. You may have noticed I have a typo here. I will use that to demonstrate how to check which of your maybe potentially thousands of jobs failed, and very conveniently resubmit the ones which failed. So let me demonstrate. So the simplest way to use it, just say submit.run and say -1. And -1, if you read this documentation, means interpret each line of table dot as a separate job, submit it as a separate job. So there are 18 lines of this file, so it will try to submit 18 jobs. You can use standard SQ command to see which of them are running or not, but it's complicated because you may be running other jobs unrelated, or maybe you're running multiple serial farm concurrently, which is perfectly acceptable in this package. Instead, you should be using command provided by the package, which is list run. It lists all the jobs belonging to only this particular serial farm. They have special names. The status is running at this point. Or you can use query command to list, to give you the statistics, basically, a summary. So it tells you currently there are 7 running jobs, 0 queue jobs, 11 done jobs. These are very small jobs, so it will be done very quickly. Just keep running query command until, okay, it tells you that current run is done, but there is one case which was not processed or failed. If you want to resubmit all these jobs, run another command, resubmit. But first we want to know and maybe fix what's the problem. For that, you need to use another command, status. And that command lists all the exit status of each of your execution of your jobs. You see, it's mostly okay, 0, but one of them, line 11 in your table dot file, has non-zero. If it's very long list, you may want to use -F. It will list all the failed jobs at the end. So you probably want to go back to your table dot, find line 11. Okay, here's the problem. We have a typo. We fix that. And then you use a resubmit command with the same argument as your submit. So just add re. And now it will resubmit only the cases which never ran or failed. This is very convenient. You still can use the standard query. And then you wait 30 seconds or so. It will eventually finish running. Let me demonstrate that to make it complete. Or you can use list run. So it's still running. Just probably a few seconds left. I just want you to see what's the proper message when everything has done successfully. Okay, this is what you want to see. The whole serial farm is done. That means there is no fails, no other cases to be processed. The whole farm is guaranteed to have been finished. Very convenient if you run lots of jobs and maybe cluster goes offline, you go back and just say resubmit, and it picks up where it left, basically. It only runs jobs which it needs to run. It can be very, very big time saver. And I may have just a few, maybe a minute or two to show a different version of the same package. So you can see a bunch of files created here. You can use clean script to clean up all of this stuff, and it will only leave the job script and table dot and a few things which you need to keep. The rest has been deleted. Sometimes your jobs are very short, as in this example. You need to run hundreds of thousands of very short jobs, which are like seconds or maybe a few minutes long. You shouldn't be submitting them as individual jobs, as I just did. Instead, you have to bundle them up. And this meta package does it very, very conveniently. So you say submit, but instead of -1, you say how many real jobs you want to run. So I want to process my 18 cases, 18 lines in my table dot, using fewer real jobs, let's say only 4. And I can do that. So what it does internally, it will run only 4 jobs, the ones I just submitted. I call them meta jobs. But those 4 jobs will eventually process all of the lines in the table. And it will also use dynamic workload balancing, which means if particular meta jobs happens to process mostly short real jobs, it will process more of them. If another meta job, let's say number 4, will happen to process only very long lines from your table data, it will happen process fewer of them. So at the end, they will finish more or less at the same time. It's called dynamic workload balancing. It can be very, very efficient way to run lots of small and short jobs. Otherwise, all other commands work. The only command I didn't show you, kill run. If at any point you want to kill any of your farms, you execute kill run. You can run more than 1 farm at a time, but I don't have time to explain that. Let's go quickly to my slides and the final topic of today. All right, I promised at the beginning to teach you how to run interactive GUI applications efficiently. I showed you how to do that using X11 forwarding, which can be perfectly fine for simple applications, but for large applications like visualization, it may be very slow and inefficient. Instead, I told you you have to use a VNC mechanism. Here is the documentation explaining how to do that. It's quite simple. So what you have to do, you have to install a Tiger VNC application on your computer. And there are versions for Linux, Windows, and Mac. And you run VNC viewer part of this application. And inside, you type the address gra-vdi.computecandle.ca. So what happens? It will allow you to access special nodes which were set aside just for the visualization purposes. So these are not compute nodes. These are special visualization nodes which are shared by multiple users. So if performance may not be the best, but they have pretty nice GPUs. So if you do some GPU-intensive GUI, like visualization, it's available. So let me demonstrate how to do that. So I'm going to my workstation. By the way, I can kill my Globus application now. Disconnect and kill. And I'm going to say VNC viewer. I already installed Tiger VNC application. I have to type gra-vdi.computecandle.ca. It remembers last time I used it, and press connect. All right. And what happens? I received a new window is open, which is a Linux GUI desktop application, allowing me to access these dedicated VDI nodes on Graham cluster. Here I have to type my login name. These are my Compute Canada credentials. Just wait a few seconds, and I have access to GUI Linux desktop. It gives you some very useful pointers. Please read them carefully. But basically, what you want to do, you want to open terminal. So click here, you open terminal. So you see the home files from your Graham home file directory. You can go to inside your project or Scratch. It's all mounted there, so it's very convenient. And in terms of software support, most of software is not available as is. Instead, as these instructions tell you, you have to say module load standard environment. Sorry, I'm running a little bit over time. I'm almost done. Standard environment, and then you're done. Then you can say module load, let's say ParaView, which is a visualization package, ParaView. And I'm going to kill this. And then I run my GUI application in a dedicated graphical desktop using dedicated hardware. Voila, so you can run it here. You share it with other users, so you don't run anything really computation intensive, but you have access to fairly decent GPUs. So I'm gonna show you NVIDIA SMI. So we have so-called Tesla M60 GPUs, multiple GPUs shared on VDI nodes. So you can get pretty decent performance using this VNC mechanism. So it is more preferable compared to X11 forwarding for intensive stuff like visualization. Thank you for your attention.